Okay, moving on to our problem here actually. So yesterday that we have seen that when I was just trying to do this particular thing, this is the displacements. Now you know like when I just go for this particular displacement and to the reach conditions also, if I just see this, in the reach conditions it was saying that it has been reached up to like 79.70 kilonewtons. Okay, so for the same thing actually what we thought, we just went back and view the calculations over here. And when I'm trying to view the calculations, I would like to try to plot a graph between that actually. So now when I was just trying to plot this particular graph, okay, so I've just seen this one. So when I was just trying to plot a graph, so I can just say that on to the x-axis, I just wanted my input as an end stage, or else on the x-axis also you can just go force, and on to the y-axis, I just want it as my input actually. So this way also you can able to do this. And okay, as this is a phase two, now this is a good example. I can just teach you one more thing. Now what happened is like I have like initial phase, I have phase one and phase two. Now actually the phase two results are also plotting it over here. But now I don't want to plot this particular phase two results where I wanted to show my graph only for phase one. So in that particular cases, you can just simply right click here, go to settings, or you can use the shortcut key of like F3. Okay, once if you use this one actually, here if you just click on this curve one, and in the curve one there is an option called as a phases. If you just click on the phases, so I wanted to show for initial phase, displacement phase, I don't want to show for the phase two. Just give OK, apply, and then give OK. So this is how actually you can able to see this particular things and all. This is where like my force, and the force is something around like, if you just see this one, force is around like an 80 or 79 point change. That was the exact force that we got it. And this is the sigma m stage where it is, you are giving it as an input. And if you see that the here it is not just an 80, it is an 80 kilonewton per radians. If I just wanted to convert this particular kilonewton per radians into this thing, so you can use this. So kilonewton per radians to kilonewtons, if I just wanted to convert this particular things, so it is just as like as a 50 radians per second, or like yeah, even in the material actually they have given it. It's maybe in the online you can check, you guys can check it. It is just by multiplying with that particular 2 pi that you are going to get those particular values and all. So now actually what happens, this is the value that I got, it is something e into 2 into 3.14. Hey, sorry, it is like 2.14 is pi value into 2, that is 2 pi, 4.28. Pi value is 3.14, right?
3.14.
Yeah,
3.14.
3.14.
yeah. 3.14 into 2, that is like 6.28. Now I'm getting like an 80 divided by 6.28. This gives me like around 12.73 is the force that I just need to apply it. So when I just convert this particular kilonewtons, that is the force that I need to apply it. Now let me go back. Yes, I would like to save this. Now on to this particular displacements. Now it's a line load, to the line load, and to the line load, that you have a value of like minus 12. You can just apply this. That is the value that you just need to apply it. Okay, let me try to solve this particular problem. Yeah, ignore.
What is that thing? Calculate all cases.
No. I have not marked it because everything is calculated. I have not marked it. So suppose if it is like this, when you just try to click on this calculate, no forces have been marked for the calculations because everything is already done. So if I uncheck this one and click on it, that error won't come. Okay, got it?
Okay.
Yeah. Now ignore that and run this particular thing. Okay, now the problem, it has been run successfully. When I just clicked on this particular thing, I can't see the reached values or something over here. I can't see the reached values or something, but the 12 kilonewton per meter, 12 kilonewton per meter squares of the load that it has been applied. Okay. Now, if I just go for the view calculations, this is the 2 pi. Nowadays I'm becoming bad and yeah, that's a thing. Now after this actually, the displacement is like very small. It is like 0.013, but it should be like 0.05. So let me open this and then see how they are converting it. Okay, you guys can use this particular site also just to look into this. It is like a settlement of a circular footing on a sign. Even direct from Bentley website that you can able to download all these particular files. Even I used to download from here and then only I'll upload it over there. So this link I have already shared with you guys. So when I just go for this thing, there is a calculation, they have explained it. So the one load that we are applying, generate the meshes. Okay. Yeah. Now, if you see this in the section of the figure 25, actually, so on the page number 36, this is figure 5 on page number figure 25 on page number 36. This is where actually that we have to apply this. So assign minus 188 kilonewton per meter square. That is like 188 kilonewton per meter to the vertical component of the line load. Note this gives that the load that is approximately equal to the following force that was obtained from the first part of the structure. That is like 188 kilonewton per meter square into pi is nothing but 590 kilonewtons actually. So that gives you, this is what actually, it is not 2 pi, it is pi into, okay, into a 1 meter square actually. So 188 into pi. It's 2 pi, right, normally?
2.5 for overall.
Okay. Yeah, only for kilonewtons. And if you want it by an area, then divided by 2 actually. Okay, it's 590 kilonewtons. So suppose now actually what I got the output as like 70 kilonewtons as an output. Now if I want by 70 kilonewtons as an output, actually what I need to do, 70 kilonewtons that I need to. So now this side I have a 70 kilonewtons and this side what is the value that I need to remember that and into pi. So 70 divided by pi, 70 divided by 3.14, this is where like 22.29 kilonewton per meter squares of the load that I need to apply. 22.29. Let me check this. minus 22.29, 22.29, and only this one, right? So I'm just calculating this again. So let me go on to this results. Okay, now it's done. So go this. For the displacement or for the phase 2 actually. So now go to the deformations, phase displacements in y direction. This deformations, total displacements in, sum of the phase displacements or the phase displacements or the incremental displacements. Okay, I want like only the phase displacements. Phase displacements, so this is like around, okay, it's hardly around to 0.025, I can say that. So that I have to multiply with the 2 pi is the right one, I feel, but I don't know in the document why they have kept it like this. So divided by 2, like again I wanted to multiply with 2 into 1, 44, 44, let's solve this. Now view the results of it. 2, and if I just go for the deformations, phase displacements of some of the phase displacements actually for that particular phase, it was around 0.05565. Yeah, that is where into 2, that is what I remember it. I don't know what the document it says it, but try to correct that particular thing. So the 4, if I apply the displacement, the force I'm getting it divided by pi into 2 I have to do. So that's where I will be getting the total kilonewton per meter square per area. What was the load that I can able to apply it? So if I apply that particular load, now it is reflectly matching with my displacements also. Now if I just go, when I apply a displacement of 0.005, sorry 0.05, now it is showing it is like 0.059. Now when I go for this particular things, now actually it was showing me like 0.05565. Okay, so which is coming at element 314 and node 4, and here also if you just check this, this is coming at element 300 and node 349. So it's all vary to vary, because when you just do this particular small verification, small changes, the element numbers and everything will change it when you are doing the meshes. But you have to identify that location, and then you have to go for this. So the location for both the things, it's all like the same. It's all deviating it, and it's all like you can just go for this. Okay, so just put control 2. This is like total phase displacements, and this is the total phase displacements all the time that you are going to put it. But now, if they have given some directly a load for you, actually in this particular problem, what they were telling is like, they have given directly a load, assign 188 kilonewton per meter squares of a load. So, but normally you won't get this particular load in terms of MPa or GPa, but always you'll get the load in terms of kilonewtons only. Okay, MPa or GPa is nothing but your kilonewton per meter square, or kilonewton per mm square is MPa, kilonewton per meter square is like something. Yeah, okay, into that. So you won't get this particular input in terms of like a pressure actually. You will get always the input in terms of like a force only. So when you got like 590 kilonewtons, then you have to apply that as like a 188 kilonewton per meter square, and this is the formula that you just need to follow for this. So when you just got like 188, so what I need to do, I got the input of like 590. So now the 590, I would like to divide it by pi into 2 that you have to do. So then automatically you can able to get this particular thing. Let me do for this calculation. So we have like 590 divided by 3.14 gives me like 188, 187.8 into area. Area is like only 1 meter square. Oh, okay. You guys find the problem?
Hello.
Okay. It's 2 meter. What was the length? I'm just going here. This was about like 1 meter length. Okay. Yeah, 1 meter square actually. That's where I have to do it as length into. Yeah. So guys, stick on to this particular formula only. But this should be always 2 pi. I don't know. Maybe Prabhakar sir, can you explain it? You might have explained this to so many students. Converting this kilonewton per radians to kilonewton. Okay, but anyways, please check this, guys. I'll also come back to you on to the next class. But here actually they were
Maybe
telling this.
this
Sorry.
if just like 590 kilonewton is applied on the whole circular footing, or and
No, no,
188
no, no, no,
kilonewton
no,
per meter.
no, 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 no,
Oh,
no, no. You have got an
okay,
input of 5K. See, here you are doing only a half of the model, but don't think that you are doing only half of the model. Software is going to assume the full model, right?
okay.
So in the backend, software is assuming as a full model. Don't forget about that. Okay. So yeah, moving on to this actually. So now I would like to create a one more footing where this particular footing I would like to call this particular name as a flexible footing. I would like to call this particular things as a flexible footing. Now, when the flexible footing is coming, yeah, and one more thing, guys. Moving into the before getting into the flexible footing, I would like to tell you that any kind of a problem, always try to achieve it with displacement values only, because each of our analysis is a plastic calculations. It's all depends upon your stiffness multiplied by your displacement gives you the force. But if you apply the force actually, what happens? Force matrix has to be divided by the stiffness matrix. You know, while calculating the matrices, division is a very difficult task. But while calculating multiplications in the matrices, it is a straightforward calculation. So always, though if you don't know the load, just keep it as kilonewtons as the load and try to achieve the displacement, and for which displacement that you could able to achieve that particular 79 kilonewtons. So in that particular way, you try to work out on this. So then only your convergency equations will be quite normal. It would be very easy to achieve it. Okay. Yeah. Now I'm going for a flexible footing. Now onto this particular flexible footing, I would like to apply this. What's the difference between a rigid footing and a flexible footing? Rigid footing is directly I'm applying the load or a displacement onto the soil layer. Now onto the flexible footing, I need to design my footing itself. So to design my footing, what I need to do, I just need to go here and I would like to create a plate. I would like to create a plate element. Now you just consider this one and this one. So as I don't have the specific geometry is all blah 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 for this, so I would like to create only just a plate element for this. Okay, now I just created a line as a plate element. So now just go to the materials. Now in the materials right away, you should not click the new material here and should not add the ones. You have to go to the plates over there. Now you created a plate element, or you created a which one actually you have to go, and then you have to go for this particular thing actually. So you have to go here and then you are creating a plate element. So when you are just creating a plate element, Make sure that in the materials when we are creating it, go to the plates and then you can just click on this new. Now this is where like flexible footing is the name of this. Okay, and now I would like to provide behavior of this, whether it's an isotropic behavior or an isotropic behavior. You have to feed this, and then the material type, it's an elastoplastic or elastic plastic or an elastoplastic materials and all. MK model you are using it for the deformation, or like it is just an elastoplastic or an elastic. So majority of the cases in civil engineering goes with elastic only. Even that includes in structural analysis also, you go with elastic only. Okay, so now when you just come to this, you have to provide to the cross section your Young's modulus multiplied with area 1, that what is the value that you need to provide it, and your cross section, I mean your Young's modulus with the area 2, what is the value that you need to provide it, if applicable in third direction. So here it is not applicable. So you have only a planar directions, only a one area that you have it. So that area multiplied with the Young's modulus, provide that particular value over here. Then you have to calculate the inertia, moment of inertia, I value. I value, it has to be multiplied with your Young's modulus and feed that value over here. And if you have a diameter, you can able to provide this, but here it will not allow you to feed the diameter because the section that you are defining it in terms of like a inertia itself. So once you provide this particular inertia and Young's modulus values, the diameter or like it is going to be calculated by the software automatically. If it is a width or if it is a circular object, then it should be like a diametral kind of thing. Okay. The next is like kilonewton per meter square. This is force value. I mean to say, for any kind of an isotropic material, what is the maximum ultimate strength that you have it? I mean, uh, you can't provide an ultimate strength here. You can just provide up to like a yield strength values and all, because this is an elastic behavior. If it is an elastoplastic behavior, then you have to provide a ultimate strength of your material. Maybe if you are taking as a steel ka yield strength that you need to provide it here. Okay, and then what is the Poisson's ratio of that steel? And if you have any damping ratios for that particular material, you just provide those particular values also over there. Now here you have it. Let me go here. So where you have the material properties for this. So it's an isotropic material, axial stiffness E1 and bending stiffness EI, and the Poisson's ratio it is having it. And the material type is an elastic material, unit weight is 0. So they are not feeding any kind of a unit weight over there. So prevent punching, if anything is there, you have to consider that punching too, or else you should be like a no, because you should not consider it as a plain. The same plate element, it is going to be used as a sheet piles also. So in that particular case, I don't want to consider the plain one. There is some kind of punchings and all on that, embossings. So those also will reduce the strength. So I need to consider those particular things. So now let me go for this. So I have like EA1 is 5 E6. So this value I have it like 5 E6. The next is like 8.5 E3. So that with the inertia value, it is like 8.5 E3. Make sure that if I'm providing the values, then automatically it's calculating that. Okay. So, and then what is the strength actually? Strength they have not given here. So if you specify that particular strength, that is well and good. If you are not specifying also, but you have to take care while plotting the results. Beyond that particular yield strength, if something is going, then your material is failing. And the Poisson's ratio also, they are going at 0, but in reality it should not go like 0. Either it should be like a 0.29 or something. In cases like a 0.22 also, it would be a right solution or not. So provide the materials rightly. Even in the document they have not given the right values, but you just try to provide it. Okay, and the damping values, if I have it, I will do that. And if any punching is there, I will click on this particular punching tool. Okay, if I just click on this particular punching, if there is no punching, just give okay. Okay, okay, sorry, I have not given this. Name is like flexible footing. So make sure this guys how to create a plate elements and all. Now just give okay. After clicking on this, now you have so many line displacement, line load, and you have a plate element also, because on a single line all these three are there. So now on this material you can just simply drop down and select that particular flexible footing. Okay, this is how you can able to assign a material to the plate elements. You got it, Vivek? Now how to assign that? Vivek, am I
How
audible,
did you
guys?
get this on Section Explorer? Hello.
Sorry, yeah, tell me.
Uh, how did you get this on Section Explorer? I'm getting nothing.
See,
I'm
you
getting
have to go to the
a
structures
size.
module. You have to be in the structures
Okay.
module.
Yes.
In the structures module, just click on this line. If you select the line, it is highlighted in the red color. Then see in the selection explorer, you have like line 1. And for that line 1, you have to take care of the displacements or the line loads, or it is a plate element. So it's a plate element. Under the plate element, material will become. So in the material, if you can select drop down, you can choose that material. Are you trying? If you are trying, share your screen. I can help you. Is it clear, Vivek?
Actually, I'm not getting that in materials flexible footing.
You have to create a material. That is the name I created.
Yeah,
That is just a name I created as a flexible footing.
okay, got it.
You can name this as a plate 1 or a steel material or aluminum, whatever you want, or a concrete block. That is
Yeah,
just a name.
got it. Thank you.
Okay, fine. Yeah.
Yeah.
And then go to the mesh. As you just change something into the structural elements, always try to go and click on this mesh. And then go to your stage construction. And then as the mesh I've done, so I need to recalculate it, all those things. So initial phase input, this is an initial phase input, and this is an initial phase input. Now if I just go for this particular flexible footing, now in the flexible footing, I would like to activate the line load. And if you just expand the line load of here, so this is what actually it is like negative directions of like, okay, now this is where I would like to apply it as like minus 188, but the problem that you got it as like 590 kilonewtons, but what you need to apply is like, so the 590 kilonewtons you have it divided by pi will gives you like what you need to apply. So 188 kilonewtons the load that you need to apply it for here. So once if you apply this particular load, now you try to calculate this one. So I'm just calculating it for all. So calculate this, then automatically it will show the results for all the things. So automatically as an additional structural element is coming in picture, that's why the mesh will change again. So that is the reason initially when I'm solving a problem, it is not taking much time. But now when I was trying to solve this particular problem, it is taking more time. As the number of elements in your problem is keep increasing it, the solution time will also increase, because for in each element it has to solve 15 governing differential equations. Now see this, if you apply a load, how quickly it is solving it. Oh, that's good. Soil body seems to be a collapse. Please inspect the output results. Accuracy conditions not reached. So it is like the line load that I have applied it, and the material properties also I have applied. Okay, let me click on this one. Okay, the plate element I have not activated actually. Yeah, I just activated only the line load, but I've not activated my footing. So I just need to activate my footing as well. I need to activate my footing as well, the plates. So, and again uncheck this one and then try to solve this. These errors and all, I would like to expect to come this particular errors. That's why I wantedly or deliberately sometimes I used to miss this then. So that once an error comes, you no need to. Now your thought is like always go back and change the mesh. But you have to think in a different directions also. That's the reason I just showed this. Now when I just look into this, oh, I realized it. Yeah, okay, the plate element is not activated, that's why. So whenever any failure is coming, try to think in all the best possibilities that without changing anything, that if you can able to solve it, that is really good. Okay, now this is where like my flexible footing is also got done. So now I'll just go for view visualizations. I mean to say, like you can say that view calculations too. And now if you just go put control 2 over here, this is where like, so your 188 kilonewton per meter square, that is nothing but 590 kilonewtons with a plate element in between the soil and to the load that you applied. The plate element, I'm going to call it as a foundation. With the foundation, if I want to reach to a point nearer to 0.048 is nothing but 0.05 meters, you can say. If I would like to reach to a 0.05 meters with the footing, it is capacity to take up to 590 kilonewtons. But if it is like without footing, directly if you apply the same displacement, it is failing at 7 or 80 kilonewtons itself. So an addition of a structural element will helps you to improve this much. So we have done like two different problems, right? So what was I mean to say, I'll just put it in this diagram itself. So you are doing this particular problem in a rigid footing. Rigid footing is the one, and the one more that you are trying to solve it is like a flexible footing. And when you just go on the results for this, it looks like this. The results are like this. So in a rigid footing, actually what we are trying, apply the displacement directly on sand. And whereas in a flexible footing, actually what we were trying create a plate as foundation. Create a plate as a foundation and apply load. And apply load. Now to the results, actually, if you just see this thing. So here we were applying it, and we 0.05 meters is the displacement that we are applying. So for that, the load that we got it as like an 80 kilonewtons is the input. 79 point something, you can round figure that as an 80. Okay. So now 80 that you got it. Now with the same thing here, if you are just going for this particular results, you are applying 590 kilonewtons, that is nothing but 188 kilonewton per meter square. So the output that you are again getting it as like a 0.05 meters. Okay, so now I would like to calculate this particular problem as a reverse condition. So how we solve, how we solve for the first case? In the same way, I would like to go for a reverse calculations for this. Now, the reverse calculations, I would like to say, create a plate as a foundation and apply displacement. I would like to apply the displacement. So apply the displacement to something like 0.05 meters. I would like to apply the displacement. That should give me something like 590 kilonewtons as an output. That is nothing but like 188 kilonewton per meter square. As this particular problem is an axis symmetric problem, so the 2 pi's and all will not applicable for the remaining things. It is only applicable for axis symmetric problems.
He is not considering 360 degrees, he is considering 180 degrees. So if you consider a circle up to meter, maybe considering 1 meter, the section is rotated in 180 degrees.
Yeah.
So he is multiplying with pi, not 2 pi.
Yeah. That's why he is multiplying with 2 pi.
Multiplying with pi.
Yeah, visualization wise, you are applying it only for half, but software will consider for the other side too as well.
I'm talking about visualization only.
This is for axis symmetric model. This confusion, you will be getting it only for axis symmetric models, not for the other models. Yeah, now let me go back. So the same thing, initial phase, take one more phase, and in this particular phase also, I would like to activate my plate elements. Now I would like to activate the line displacements, and the displacement value that I would like to apply is something around 0.05 meters. Okay, I'm not activating the line loads, so I'm activating only the line displacements over there. So the line displacement is activated and there is a no line load, and as well as the plate element is also activated from this. Yeah, now try to calculate the solution. Now when you apply the load, it took simply it's all data because it's straightforward. But when you applying this particular displacements, actually the real calculations are happening it. So it will take a lot of time to rectify that. So it will always take time. When you apply a displacement, it will always take time and your results will be like more accurate. But if you apply a load, actually, it will take very less time and your results will be less accurate. For this particular simple problem, you can't see the much deviations, but when you go for a bigger problems, you can see the deviations. Okay, now viewing on the results again. This is my phase 4 and now put control 2. So this is where like actually I applied 0.05 meters and now it has been done up to like 0.05 meters. And in the phase 4, if I see the reached values, you can see this. It is where like 95.43 kilonewtons of the load that it has been reached it. 95.43. So now this is for half, right? 95.43 into 2. It is nothing but your 188 kilonewton per meter square, I told, right? That is nothing, nearly it is coming around like 190.86. So always accept this. This is a software which gives you deviations of 2 to 3% all the times in mathematics. So that's why any of mathematical or finite element solutions for a complex problems, if it is beyond 85%, then the problem is an accurately corrected problem. So 15% deviation we used to take it in the complex solutions, but for simple solutions you can take 5% deviation. So that's where actually now it has proved that we were reaching up to that 188 kilonewton per meter square of the load. And that 188 into pi into a 1 meter square that we are applying it. So that gives you like total 590 kilonewtons of load that is applying. Is it all clear?
Yeah.
Okay. Try all these particular cases from your end too. Try all these particular cases from your end. And as a homework, I will solve. I'll tell you one thing. Only this particular thing only. In the same geometry, what you do, in the same geometry, go to your structures element. You can look into my recording video and then you can do that also. And I'm just going to create a particular line element. So from here to here to here and to here. So I'm just creating a line element and I'm just going for the mesh again. I will generate the meshes. Now to the flow conditions, nothing changes. Going to the stage construction, this is there. Again, you can activate this one. And in this one, actually, I would like to activate the plate elements and I would like to activate the line displacements. Okay. And then I would like to click on this one, right click and deactivate. This is where you are doing an excavation. So now I have cut this particular part. It is rotating 360 degrees. So around the circle, actually you are digging this. Okay, a circular portion around to this particular foundation, you are digging this.
Annular.
Now when you dig this, hello?
Like annular.
Yeah. So now when you just go and run this particular solution, just trying to solve it from the beginning because we have a mesh change. So whenever any mesh change it is happening, we will lose the complete records. We have to wait for the beginning. So now maybe whenever we are solving and this particular screen is coming up, please look into that, the values that I'm telling it. So depends upon your CPU number of cores, availability, free availability, that automatically it will take it. Maybe in few of the machines, it may be show it as like 4 out of 6 or 6 out of 6 also. Okay, but for Plaxis here in my machine, I was limited to that. Okay, that's cool. This is what I'm expecting. It. All the things I will try to come up with an error, and then I would like to show you that particular parts. Now, when you just end up with an error, again it says that the soil body seems to be a collapse. Please inspect the output results accuracy condition not reached and error number 111, the same error, and try to don't go back and change the mesh again, or try to look what you can able to do it over here. Everything is good as per the expected thing. Okay. You didn't got any thought on your mind what to do next. So just try to visualize the results first. So this is the phase that I got it. Now when I just put this control 2, now if you see this particular thing actually, I see some kind of a deformations here. I see there are a slight deformations which are happening over here also. And moreover, you see that I have applied like 0.05, but it has been applied like only 0.03. After that, actually, because of this pressure coming over here, we are losing some stability onto this particular side. We were losing the stability onto this particular side. So, okay. Now, this is what actually I understood from the problem. Maybe it may correct or may not be correct. So let's say that I would like to reduce my excavation depth. Okay, if you want to adjust this particular problems, 3 to 4, and it is like minus 0.5, minus 0.5. Okay. Now going back to the mesh again, generate the mesh. Done. Go here. In this particular phase, don't deactivate it. This you should just activate it. Only this part is deactivated. Now try to solve this.
Can you show me again
Please.
how it is deactivated? Just
Now I
missed it.
can't show that. You have to
Okay.
click on the soil, right click, and then activate and deactivate options, both it will come.
Fine.
Guys, remember that when you are trying to solve for the very first problems, if you are ending up with successfully completed, then please remember that you are doing something wrong. You have to come up with an errors. Errors only will help you to self-learn so many things and all. So that's why you have to remember that what you are doing it, make sure that where exactly if I do something wrong, this error will come. That also you should learn. That will all comes when you are practicing more and more. Now I realized it, the depth of like 1 meter excavation is quite challenging for me to do in a single phase. Let me try whether I can able to excavate 50% of it, like 0.5 of it. And now, how do I come across this particular 0.5 is also matters a lot for me, because when I just look into the results, I see the maximum displacement on that particular thing is like 0.03 meters. The total I applied is like a 0.05. So out of 0.05, if it is coming 0.03, what was the percentage that I could able to solve it successfully? Now see this, the reached values. Now go for this again. Even like for 0.2 excavations over there, now it's like a 0.04 meters actually the depth that is going on. That's really cool after doing that particular change, like the excavations of this. But still I could able to excavate it only like 40% of this. Okay, so previously I was able to do only 30%, and after reducing that I could able to do up to like 40% of my excavations. So now what I need to do, I'll just go back now exactly of this particular thing. I mean 0.5 meters of the depth I want to go. Out of that 40% it could able to successfully complete it. So go for a thing, just put 0.5 into 0.4, 40% you can able to complete it. So now the right value, if your problem need to solve it successfully, then you have to make this as like minus 0.2. Okay, you have to make this as minus 0.2. Now go to the mesh, generate the mesh again, go here on this, here you have to click it, sir. You have to click, right click, activate or deactivate. You are going to come. If it is activate, everything is activated. Now I have to click this one, right click and deactivate it. So only 20% now. I've just been removed it. Now I could able to try to solve this. Now there is a 90 to 95% chances there it will pass, but still I have a doubt like a 10 to 5% it may fail, because exactly I meet with the requirement of like initially of like 0.5, where it could able to do the 40%. It is something around like 2. Exactly I fixed it look 2 meters. Now will it solve sometimes, but it will not solve sometimes. But if your problem is too high, make sure that the 0.2 value I got it, make it as like a 0.18. Go for the excavation depth of like 0.18 and then try to see whether you could able to solve the problem or not. I know it is just for our homework. Don't worry. Try these iterations. and try multiple times or whatever you wanted. Come up with different numbers and try to achieve the solution whether it is working fine or not. Just try to achieve the solution whether it is working fine or not. If you end up with more errors, that is really good, so that I'm here to help you out how to clarify all those particular errors and all. So don't worry. Now let's see. 90% it will solve and 10% it may fail. If it is solving, that's really good. I say 90, not 100%, because of exactly I take the mark of 0.2. If I could have taken a mark of like 0.15 or something, then I could have said it is 100% it will excavate. That's where actually now the excavation is happening. Okay, that's where my guess got cleared it. And based on that output, I see what is the displacement it is happening. So how much amount it could able to excavate it, I realized it, and then I was just moving forward the solution to that particular phase. And the next step again, I can go for another 0.2 level of an excavations. And if it is running fine, you are doing an R&D, guys. So you can just increase that 0.2 to 0.3, and then you can go. So this is where the suggestions that you can give it to the site engineers when you are excavating at the site. You can go for this particular depth without any consolidations. I mean, you don't need to wait for the particular times. You can excavate it. And after that, you can just go leave it for consolidations, and again, it will stabilize it. And then you go for another day of excavations and all. So this kind of suggestions that you can able to make to the site guys and all site engineers. So this is how actually you can able to solve this excavation problems. And there are many other things where you can able to add the supports and all. So slowly we are going to discuss about those things. Any doubts till now that whatever we discussed today?
That stress contour, if you draw from the, let us say, load to the excavation, last time it was showing there is a tendency to fail. Now, what is the situation now?
Yeah, now it won't fail actually.
I just
There
want to
might
see
be
this.
a recorded values, but it won't fail. Now you see that previously you have a tendency of that, but
Yes,
now you
yes.
don't have.
Content. It is not reaching up to there.
Yes. Okay.
Thank you very much.
Hello.
Clear. Now, keep it in mind when you are doing an excavation problems. If you choose a drained material behavior, what will happen? And for the same excavation process, if you choose an undrained A conditions, both the things are possible in the site too as well, and depends upon the depends upon the laboratory results that you are getting. You are choosing it over here. But if you are doing an excavation problem, you always recommend to the lab guys saying that I want a drained or an undrained A. So just keep this particular point in your mind and try to solve this. Maybe you can just do by changing drain to undrained A behavior and try some solutions. End up with errors only. I'm not expecting to come up with some good results. So end up with the errors and come back to me so that we will discuss those things.
Hello.
Okay, is all clear?
Yeah. Hello.
Yeah, Bharat.
Right?
Sure. Sorry, Ashok,
Bharat.
Bharat, who is calling?
Yeah.
Bharat has raised up a hand.
Yeah.
Yeah,
Can
Bharat.
I model a footing at a particular depth?
Yeah, first
Now,
you have to yeah, you can do that. You can do that.
without excavation.
Without excavation, also you can do that. Yeah.
Okay. Now we are
In
after.
reality, it is not possible. In reality, it is not possible, but in software, it is possible. Yeah.
What about the results?
Results will be matching to your reality only.
Okay. If first of all in staged constructions, if I excavate, suppose my footing depth is 2 meters.
Hmm.
In general, first we have to excavate up to 2 meters. Then I have to construct the footing.
Hmm.
Okay.
In reality, that was a process. In reality.
Okay.